Alright guys, it's Mr. Sands here. I've had a lot of people tell me that this homework was a little tough, so we're going to walk through it. We've already done some of it in class, but if this is working all right, I should be able to show you exactly what I would do if I had this as homework. First off, obviously you're going to put your name. I'm doing this on Sunday, and then, whatever period it is, let's say it's fifth hour. Okay, so we're looking at kind of the same thing that we've done in class. We have a bridge thickness experiment. We have thickness here of 2, 4, 6, and 8, and they vary according to the breaking weights of 15, 30, 50, and 65, respectively. You can go ahead and erase those. But you see this is what we're looking at. So it says, plot the thickness breaking weight data. Draw a line that models the pattern in the data. So if I move this up, the first thing that we have to do is label which is our x and which is our y-axis. And we always know that our y is going to be horizontal and our x is going to be, our y is going to be vertical, and our x is going to be the horizontal, like so. The y-axis, we said before, that's going to be our pennies, and our x-axis is the bridge thickness. Okay, so the first thing we're going to do is we have to figure out what scale we need to use. Well, the thickness has 2, 4, 6, 8, so we need to go up to at least 8. And let's count how many lines we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so we could do 1, make a scale of 1 to 1. Or we could do, if we do a scale of 2 to 1, is that going to give us enough? I don't think it is. Because if we do a scale of 2 to 1, that'll be 1, that'll be 2, that'll be 3, that'll be 4, that'll be 5, that'll be 6, and that'll be 7. We won't even have enough to do 8. So it looks like we're going to have to use a 1-for-1 scale here, which makes it pretty easy. Remember, our first one is always going to be 0. So 1, 2, 3, 4, big one at 5, 6, 7, 8, 9, big one at 10, 11, 12, 13, 14, big one at 15. Now, going up and down, we need to get to at least 65, but how many lines do we have to begin with? Again, the first one would be 0, so this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, so we have 17. We got a little side problem over here. So 17. We can't do 1-for-1 because that would only give us 17, and we need to show at least 65. Well, 17 times 2, if we make each one 2, I still don't think that's going to be enough because 17 times 2, 2 times 1 is 2, plus 1 more is 3. So we can't do that. What about 17 times 4? If we do that, 7 times 4, that's our 28. 4 times 1 is 4. 5, 6. Okay, that could be enough. We have each line represent 4 pennies, and we would cover at least the 65 that we need to show. But what if we went one more? 17 times 5, because that would give us a little room for prediction if we wanted. So 17 times 5, that's going to be 35, 5, 8. I like that because that not only covers the scale that we need, it also is going to give us a little bit of room to make predictions and go beyond. So this is 0. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, Okay, so what did we say? That each of these represents 5. So 5. So this would be 5, 10, 15, 20. So this big mark here we could represent with 25. This would be 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, and then that leaves 80 and maxing out at 85. But you see, we put the big numbers on scale here. Okay, so now that we have that, can we plot the points? So we're going to plot the point 2 thicknesses and 15 pennies. 2 over and 5, 10, 15 up. And we need to label our point 2 and 15. We also have the point 4 and 30. So we need to put that on there. 4, 25, this would be 30. Six and 50. Here's 6, and here is 50. Last we have 8 and 65. 8, 50, 55, 60, 65. Okay, so it looks like it's a pretty straight line. I can't put the meter stick on the board and make a straight line without marking it up. But if you see, we'll give it in a different color, it would kind of look something like that. It's a line of best fit. Okay, and we already went through the equation in here when we used y equals mx plus b, where m is the slope and b is the y-intercept. We found the slope between 2 points. The slope is going to be 15 over 2. So, and the y-intercept where it crosses the y-axis is here at 0, 0. So our equation just came out to be y equals 15 over 2x. Okay, great. Now, to solve the last problem here, it's actually 3 different things that it's asking us. It says, use your equation to predict the breaking weight of paper bridges 3, 5, and 7 layers thick. Well, you notice that we have our scale right here, so we could predict by looking at the scale. So you see this would be 1, 2, 3. So 3 should be somewhere right here, which kind of looks like it's 3. It's between 20 and 25, so let's call it 23. It also wants us to predict 5. Well, 5 crosses about here, and that would be 5, and that looks to be between 30, 35, looks to be between 35 and 40. So what if we called that 37, if we just had to guess, just by looking at our red line that we drew. And then last it asks us to do 7. So this is 5, this is 6, this is 7. Where does 7 cross this line at? That looks like it crosses between 50 and 55, so if we called that 7 and 54. Okay, so those would be our guesses just by looking at the line, but we could actually do this mathematically because we have an equation now, and we can plug in x, the 3 for x, the 5 for x, and the 7 for x. So we have y equals 15 over 2x, which we will get y equals 15 over 2 times 3, which is really y equals 15 over 2 times 3 over 1 if we're going to make that into a fraction. So this is going to be y equals 15 times 3 is 45. 45 over 2. 45 divided by 2 is going to be 22 and a half. So what did we guess? 23? Hey, that's pretty close. 22 and a half here. 23 here. Not too bad. Now we need to find the same thing. So we're going to start with our equation again. Y equals 15 halves times x. We plug in 5 for x this time. So we have 15 halves times 5, which we can rewrite as 15 halves times 5 over 1. So this is going to be 15 times 5. I need to do that to the side right here. Oops, 2 times 5. That would be 25. 5, 6, and 7. So that's 75 halves. That's going to reduce to what? Well, half of 70 is 35, and half of 5 is 2.5. So 35 plus 2.5, that's 37.5. Exactly. And we guessed 37. So again, we're pretty close. Our line of best fit was very, very close to the actual mathematical answer of that line. Now, the very last one that we have to do is using 7. Now, again, I always say start with the equation, and then you just plug and play from there. So y equals 15 halves x. Y equals doing one step at a time every time. So I'm very systematic in this. This time it's going to be 7. So y equals 15 over 2 times 7 over 1. 15 times 7. We have already actually done that problem right here. So you see that when I do my side work, I've actually already done this problem, so I don't need to do it again. So 15 times 7, that's 85. So 80 divided by 2, that's 40, and then again 5 divided by 2 is 2.5. So that's going to be 42. Now how did we compare there? A little bit off on that one, but we did have some data that was a little bit off the line. So, pretty close. So this one is really at 42 and a half. So 7, 42 and a half. So there's a little discrepancy there, but you see that using the line to make an estimate and actually doing the math is two different things. So that would be the front half of this worksheet. And I will make another video to explain the back.